Why is virtual work fundamental to finite element method? Imagine trying to solve a complex puzzle where each piece represents a tiny part of a structure. Now, picture fitting those pieces together to see the whole picture clearly. That's what the finite element method does for engineering problems. But how do engineers connect all those small pieces? The secret lies in a principle called virtual work. Virtual work is a way to understand how forces and displacements interact without actually moving the structure. Think of it as imagining a tiny, imaginary shift in a part of a machine. The work done by internal stresses during this tiny shift equals the work done by external forces. This idea helps engineers check if a structure is balanced or in equilibrium. Now, the real magic happens when we turn these ideas into math. The differential equations that describe how materials bend, stretch, or compress are very hard to solve directly, especially for complex shapes. Virtual work allows us to rewrite these equations into an integral form, which is easier to work with. This form is called the weak form, and it's the foundation for the finite element method. When engineers use the finite element method, they divide a big structure into small, manageable pieces called elements. Each element has shape functions that approximate how it moves or deforms. The virtual work principle makes sure these approximations satisfy equilibrium conditions on average, not just at specific points. This leads to a set of algebraic equations that relate the displacements at the nodes to the forces applied. Because of this, virtual work makes it possible to handle complicated boundary conditions and loads naturally. Whether it's a force pushing on a beam or a pressure on a pressure vessel, the virtual work approach includes these factors seamlessly. It also connects to energy principles, like the idea that structures tend to settle into a state of minimum potential energy. In practical terms, this means engineers can use software based on the finite element method to predict how structures will behave under real-world forces. They can analyze stresses, strains, and displacements with confidence. This helps in designing safer, more efficient machines, bridges, and buildings. So, virtual work is the backbone that transforms complex physical laws into a form that computers can solve. It bridges the gap between the real world and numerical analysis, making the finite element method a powerful tool for design and analysis in mechanical engineering.